All right, today we're looking at writing arithmetic sequences. And arithmetic sequences are just a sequence of numbers or things that are going up by adding or subtracting. So let's look at this one here. I've got 1, 3, 5, 7, 9, and I want to find the next two terms. So what am I adding by each time? Well, to go from 1 to 3, I'm adding 2. 3 to 5, I'm adding 2, and so on. So each time I'm adding 2. So 9 plus 2 is 11, and 11 plus 2 is 13. But now what if I wanted to find the 20th term instead of just the next two? Well, I could keep working my way up, right? But is that going to be easily feasible? No. It's going to be very time consuming. Maybe easy, but it's going to be very time consuming, especially when we want to go to something like the 200th term or the thousandth term. So we have what we call the explicit rule. And a rule, guys, is just an equation. So the explicit rule can be used to find any term in the sequence without knowing the previous term. So I don't have to go one by one. I have to know the first term, and I have to know the common difference, what I'm adding by. So here's the explicit rule, what it looks like. That n right there just is what term we're trying to find. So if we're just asked for the rule, we leave it n. A sub 1 is my first term. D is my common difference, what I'm adding or subtracting by. And n is the nth term. Again, the term I want to find. Okay, so let's take a look at this using this rule. I've got this set of squares here. In the first set of squares, I've got 3. Second set, I've got 6. Then 9. Then 12. What is my first term? Well, in this case, 3. My common difference, how am I going from one term to the next? Well, I'm adding 3 each time. So my common difference is 3. So my rule, or my equation, would be a sub n is equal to 3 plus 3, right? Because remember, it's a sub n equal to a sub 1 plus d times n minus 1. So all I did was plug in the given information. So now I want to find a sub 26, or the 26th term. So a sub 26 is going to equal 3 plus 3 times 26 minus 1. All I did was replace the n with 26. And from here, we're going to ignore the a sub 26 and just work out the rest. So, simplifying, I get 26 minus 1, which is 25. Then we do 3 times 25, which gives me 75, plus 3, 78. So my 26th term is 78. So if I were to continue drawing that out, I would have 78 boxes on the 26th term. Okay, now let's look at this one. We've already got our sequence listed out. So what is my first term there? My first term there is negative 90. What is my common difference? How am I getting from one to the next? Well, to go from negative 90 to 96, I'm subtracting 6. And I'm subtracting 6 each time. So my rule is a sub n is equal to my first term, negative 90, minus, or plus a negative 6, so it becomes minus 6, my common difference, and minus 1. And now I'm looking for what term? Okay, well, I'm looking for the 107th term. So that's my n. So a sub 107 is going to equal, well, negative 90 minus 6 times 107 minus 1. And again, from here, I'm just working out the right side. So negative 90 minus 6 times, well, 107 minus 1 is 106. Then we're going to multiply, so we get negative 90 minus 636. And then negative 90 minus that gives me negative 726. So my 107th term is negative 726. Pretty straightforward, right? All right, let's look at the next one. Now this is a table. So let's kind of look at what this table is going to look like. Okay, so my first term is 6/7. My second term is 10/7. My third term is 2/7. And my fourth term is 18/7. Now we have another term and I missed my box. I'm sorry, guys. So my next term would be 22/7. Okay. So my first term, what is that? Well, 6/7. Okay. Now the common difference, how am I getting from one term to the next? So notice all but the 2 have a denominator of 7. So all we have to look at is the numerator. How am I moving in the numerators? Well, to go from 6 to 10, I'm adding 4. Okay. And actually, if I change 2 into a fraction, which I can, right, which is 14/7, we'll notice that I am adding 4 each time in the numerator. So my common difference in this case is 4/7. So now we're going to look at this and put it in our rule or our equation. So we get a sub n is equal to my first term, 6/7, plus my common difference of 4/7 times n minus 1. And from here, guys, again, it is literally that easy. Plug in. So if they want me to find the 63rd term, I'm going to plug in 63 for n. So we get a sub 63 is equal to 6/7 plus 4/7 times 63 minus 1. So we get 6/7 plus 4/7 times 62. 4/7 times 62, 6/7 plus 248/7. Then we add our 6/7 to that. And we get 254/7. So 254, oops, I can write that better, over 7 is the 63rd term. All right, last one, guys. So on day 1 of his new day, Isaac walked 2 laps on the track. Each day he added an additional 4 to his exercise routine. So let's kind of list this out. Day 1, what did he do? He did 2 laps. From there, each day he's adding what? 4. So 2 plus 4 is 6. 6 plus 4 is 10. 10 plus 4 is 14. So this is kind of how the series is going. I'm going to fix that 6. There we go. Okay, so what is my first term? Well, 2 laps. His very first day, he walked 2. How am I going each term? Well, I'm adding 4, right? He tells us we're adding 4 laps each day. So my rule would be, or the equation, a sub n is equal to my first term, oops, plus 4 times n minus 1. Now all we want to do is find the 30th term. So now we're going to plug in 30 for n. So we get 2 plus 4 times 30 minus 1. Well, 30 minus 1 is 29. 29 times 4 is 106. And 116 plus 4 is 118. So the 30th term is 118. All right. That's all I've got on arithmetic sequence. I'll see you in the next.